Good morning. Today we're going to talk about Math 111, Section 3.3, solving 3 by 3 systems of equations. Our book, the formal title of the book is Solving Systems of Equations in 3 Variables. Typically what we have here is 3 equations with 3 unknowns. So it is an extension of what we talked about in Section 3.2. Section 3.2, solving the 2 by 2 systems, or solving systems in 2 variables. So we're extending that concept here. Let's see, solve. Let's see what we're up against here. And it is a bit more difficult than solving the 2 by 2s. Basically, we'll have 3 equations with 3 unknowns, and the idea here is good housekeeping is essential, even more essential than in the 2 by 2s. It's easy to get lost in a blizzard of numbers and variables here. To help make things a little easier, I will agree to this conditions in this section and in this section only. For the 3 by 3 systems, we'll make this assumption. They will always be given to you in standard form, and by that I mean of the form, each equation will be of the form ax plus by plus cz equals d. All right? Basically, multiple of x plus a multiple of y plus a multiple of z equals some constant. All right, so all these equations will be given to you in standard form in section 3.3, and there'll be no fractions or decimals given in the equations in standard form. All right, so no fractions or decimals, at least not to deal with initially as we go on and solve. All right, the book has a 6-step process here. Now don't panic. Let me write down the steps here. Step 1, when I'm asked to solve equations or systems of equations of this type. Well, step 1 is to get each of the equations in standard form, and of course we agreed in this section that will already be done for you in the problem statement. Alright, step 2. Pick 2 equations and eliminate a variable, as we did in section 3.2. Now, which variable you eliminate, well, that'll depend on the given conditions, the given coefficients in the system in the problem, right? So basically let experience be your guide to that. Alright, once you eliminate a variable from 2 equations, we'll then say pick a different pair. Well, of course, one of them's got to be the same because you only have 3 to choose from, and eliminate the same variable as in step 2. And basically pick another pair. And step 4. Well, steps 2 and 3 will yield 2 equations with 2 variables that you can solve. Right? I will then solve the resulting 2 by 2 system. Oops, hang on. Solve the resulting 2 by 2 system you get from steps 2 and 3. And step 5 will be find the value of the third variable. Well, we can sub the results from step 4 into any of the original equations. Let me scroll down here. to any of the original equations and solve for the third variable. Alright, so in wide strokes what we're going to do is use elimination to squeeze out a 2 by 2 system, and once I solve the 2 by 2 system for two variables, I can then sub into any of the original equations to solve for the third variable. Alright, step 6, the book cites a step 6, and that's to check. I'm going to leave that for you to do. Basically, you can always check your answer at any time in these problems by substituting in all three values into all three of the equations. Alright, I'm going to go back to that original system that we gave you. Solve 2x plus y plus 4z equals 12. X plus 2y plus 2z equals 9, and 3x minus 3y minus 2z equals 1. Alright, there is my 3 by 3 equations with three variables, and I'm going to number these equations 1, 2, 3. Things can get very complicated very quickly if we don't keep organized here. Alright, what I'm going to do, our second step says to pick two equations and eliminate a variable. I see equation 2 and 3. If I add equations 2 and 3, the z variable will be eliminated, much like we did in section 3.2. So let me write that down. I'm going to take equation 2 and add it to equation 3, and I will get the resulting equation 4x minus y equals 10. Alright, now step 3 says to pick a different pair and eliminate the same variable. We're going to want to eliminate a z variable, and I notice if I take equation 2 and multiply it, well, let's see, you know what I'm going to do? I'm going to take equation 1 right here, and I'm going to add it to equation 3 multiplied by 2. Because then I see down here 2 times minus 2z is going to give me a negative 4z, and if I add that to a positive 4z, I will get a cancellation of the z variable. Alright, so let me go ahead and do that. Equation 1 plus 2 times equation 3. Let's see, I'll get 2x plus 6x will give me 8x. Well, maybe I should write this down. Hang on a minute. Let me write it out. This is our first time out here. I'm going to say equation 1 is going to be 2x plus y plus 4z equals 12. I'm going to take equation 3 and multiply it times 2. I'll get a 6x minus 6y minus 4z equals 2. And if I add these two equations, I'll get 8x minus 5y. The z's cancel out, which is what I wanted, equals 14. Alright, so I've worked it out for you in a little more detail, and I'll write that down as my second equation here with z eliminated. Alright, the result is a 2 by 2 system, that's an 8 there, that hopefully I can solve as in section 3.2. Alright, well, let's see, let me rewrite that 2 by 2 system. 4x minus y equals 10, 8x minus 5y equals 14. I suppose there's a number of things you can do here. I'm going to take this first equation through and multiply everything through by negative 5. because I see when I multiply minus 5y times minus y, I'll get a plus 5y, and then I can eliminate the y variable. Okay? So I'll take that 2 by 2 system and multiply the top equation through by minus 5. I'll get minus 20x plus 5y equals negative 50. And the second equation in that 2 by 2 system I won't do anything to. Now I'll add these two equations. I'll get minus 12x, the y's cancel out, equals minus 36, and that looks okay. If I divide both sides by negative 12, I get x equals positive 3. Alright, if x equals positive 3, I can go to any of these equations, either of these equations, and plug in x equals 3 and solve for y. I might as well I'm going to pick the second one. Using equation 2 in the 2 by 2 system, I'll say 8x minus 5y equals 14. Alright, so if x is 3, I'll say 8 times 3 minus 5 times y equals 14. I'll get 24 minus 5y equals 14. If I subtract 24 from both sides, I'll get minus 5y equals negative 10, and y then equals a positive 2. Alright, so I have solved the 2 by 2, this 2 by 2, for x and y. Right, so x is 3 and y is 2. But we still need to know what z is to solve our original system. Our solutions will be what we call ordered triplets. In section 3.2, our solutions were ordered pairs, right? Alright, so what I've got to do now is go back to any of my original three equations. You know what x has to be, you know what y has to be, so I can plug those values in and solve for z. I'm going to pick the first one here, 2x plus y plus 4z equals 12. Write it down. 2x plus y plus z equals 12, or plus 4z equals 12. I've already found out that when x is 3, y must be 2, so I can plug those values in. When x is 3, y must be 2, and then I can solve for the missing third variable. 6 plus 2 is 8. If I subtract 8 from both sides, I'll get 4z equals 4, and of course z equals 1. Alright, so I've got a triplet solution. I'll write down my solution is x is 3, y is 2, and z is 1. We should put our answers in what we call ordered triplet form, solving for x, y, z simultaneously. Alright, so again, in wide strokes, we take our original system, reduce it to a 2 by 2, solve the resulting 2 by 2, and then put those values into any of the original equations to solve for the missing third variable. Alright, let me get a fresh screen. Let's see, let's do one from the homework list. This is going to be number 15 on page 225, right at the end of section 3.3. And let's solve the following 3 by 3 system. X plus y plus z equals 4, equation 1. 2x plus y minus z equals 1. And equation 3, 2x minus 3y plus z equals 1. Alright, this is a system of 3 equations with 3 unknowns. I claim there is an ordered triplet xyz that will solve all 3 of these equations simultaneously. Alright, first thing we should do is pick 2 equations and eliminate a variable. Well, again, let me label these equations 1, 2, and 3. I think I'm going to add equation 1 to equation 2. Why am I going to do that? Because I see the z variables will cancel out. So equation 1 plus equation 2, I end up with 3x plus 2y. The z's cancel out, and I get equals 5. Alright, or rather conveniently, I see equation 2 plus equation 3 will also give me a cancellation of the z variable. Alright, adding equation 2 to equation 3, I'll get 4x minus 2y. The z's cancel out, and I get equals 2. Alright, so I've used elimination to reduce the system to a 2 by 2, and now I'm going to solve this 2 by 2 as in section 3.2. Well, this looks convenient because I see the y variables are opposites, or the y coefficients are opposites in this system. So I can go ahead and add these right away. 7x, the y's cancel, that's nice. So 7x equals 7, or x equals positive 1. Alright, I can now plug 1 into either of these equations to solve for y. So I'll pick the first one. 3 times 1 plus 2 times y equals 5. I'll get 3 plus 2y equals 5. 2y equals 2, or of course, y equals 1. So when x is 1, y is 1. Now that I've solved for these 2 variables, I can plug those 2 values in for x and y into any of the original 3 equations. I think I'm going to pick the first one. X plus y plus z equals 4. If x is 1 and y is 1, I can solve for z, and z of course equals 2. So my triplet solution for that original system is going to be the ordered triplet. X is 1, y is 1, and z equals 2. This triplet set will solve all 3 of the above equations individually. Okay? Alright, let's do one more. This one's going to be a little harder, but not too bad, I hope. This is also in your homework set. This is number 20 on page 225. Solve the following 3 by 3 system. Well, let me give you equation 1. 4x minus 3y plus 5z equals 23. Equation 2. 2x minus 5y minus 3z equals 13. Step 3. Minus 4x minus 6y plus 7z equals 7. There's a z there. Alright, and I notice right away in equation 1 and equations 3, if I add those 2 equations, the x variable will eliminate from this system. Alright? So let me take equation 1 and add it to equation 3, no adjustment needed. I'll get a minus 9y and plus 12z equals 23 plus 7 is 30. Alright, I'm going to want to pick a different pair and eliminate that same x variable. And I think I'm going to pick number 2 and 3. I can see if I multiply equation 2 times 2 and add it to 3, I will get elimination of the x variable here. So let me write that down. 2 times equation 2 plus equation 3. Alright, so I'm going to multiply equation 2 through by 2 and add it to equation 3. 2 times 2x is 4x, and 4x minus 4x is 0, so those cancel out. 2 times minus 5y is negative 10y. Negative 10y minus 6y is minus 16y. 2 times minus 3z is minus 6z. Minus 6z plus 7z is 1z, or just z. And on the right, 2 times 13 is 26. 26 plus 7 is 33. Alright, so I will use that as my second equation here. Minus 16y plus z equals 33. So we've reduced our 3 by 3 to a 2 by 2, which hopefully I can solve without too much trouble. It's going to be a little more work than the last two examples. Let me copy this 2 by 2 system down here a little bit. Make it a little more clear, I hope. Minus 9y plus 12z equals 30, and minus 16y plus z equals 33. Let me make sure I copied it right. Minus 9y plus 12z equals 30, minus 16y plus z equals 3. Okay, looks good. Alright, let's solve the resulting 2 by 2. Well, let's see, 9 and 16, I'm not going to deal with the y's here. I think I'm going to multiply the bottom equation through by negative 12, because I'll get a negative 12z in the z slot, and I can add that to the upper equation, which has a positive 12z in the z slot. Thus I will eliminate the z variables. Alright, I'm going to leave the first equation alone. Minus 9y plus 12z equals 30. I'm going to multiply the bottom equation through by negative 12. You're going to have to use a calculator here, I think. Minus 12 times minus 16. Let me get my calculator. Minus 12 times minus 16. I get positive 192. Now don't panic. I'll get a positive 192y, multiplying this times this. Minus 12 times z is, of course, minus 12z. That's what I wanted, to cancel out the z variable. And minus 12 on the right, minus 12 times 33 equals minus 396. I don't think I made a mistake here, so let me say this is an equivalent system. I've rigged it so the z's will cancel out, and I'll get 183y adding these two equations equals, well, 30 minus 396 is minus 366. And I think I see something here. If I divide both sides by 183, the 183's cancel on the left, and I get y equals, indeed, minus 366 over 183. That divides evenly, and I get y equals negative 2. Alright, if y equals negative 2, I'm going to use that y value to solve for z here. I'm going to plug in minus 9 times y equals minus 2 plus 12z equals 30 to finish solving the 2 by 2. 18 plus 12z equals 30. So 12z equals, if I subtract 18 from both sides, 12z equals 12, which of course means z equals 1. So I've got solutions for y and z. Alright, now that I've solved that 2 by 2, I'll go back to my original 3 equations, and I can pick any of my original 3 equations and plug in the values of y and z that I found. Oh, I think I'm going to pick the middle one, 2x minus 5y minus 3z equals 13. Let me write that down. 2x minus 5y minus 3z equals 13. I'll plug in y equals minus 2 and z equals 1 and solve for my missing variable x. So minus 5 times minus 2 is 10. 10 minus 3 is 7. I get 2x plus 7 equals 13. 2x equals 13 minus 7 is 6. And of course, x is 3. Alright, so now I have a triplet. X is 3, y is minus 2, and z is 1. So my solution set is the ordered triplet. X is 3, y is minus 2, and z is 1. There's my final answer. Alright, so a bit more difficult than the section 3.2 systems, the 2 by 2 systems, but not too bad if we consider all these will be in standard form. I'm not going to put any fractions or decimals as coefficients, and hopefully if you follow the systems, use good housekeeping, you'll should be okay. Alright, so this concludes section 3.3, solving 3 by 3 systems in Math 111.